Here. All right, so just to start off with, I've been getting a number of emails from students across my classes saying that, they've been exposed to somebody who's turned COVID positive and they have to quarantine and they won't be in class. I do run this WebEx and I'll continue to run the WebEx, and I've got this nice little Bluetooth in my ear so that my voice can be heard no matter where I'm standing. So if that happens to you, if you happen to be exposed to somebody who turns positive from COVID and you have to quarantine, please attend the WebEx anyway, because that will, please attend the WebEx from home, because that will keep you from falling behind in this class. So that was my first commercial message. The second thing, as I said, is if you could go on to Canvas and download the Word document that contains this table, and the name of it, you'll find that under lesson 3. It's called Relational Operators Table for Copy and Paste. You'll notice some of the symbols on this thing are missing. I'm going to add them later on. So we're not going to use assign and we're not going to use rename for now, but you should see this table in that document. And the reason I do this is when I do test you on these things, I'm going to ask you to create these relational algebra expressions in Word or in Excel. And you should get used to cutting and pasting the symbols so that you don't have to learn your Greek letters or find those symbols yourselves, okay? So this is what we're going to do today. We're going to use these relational algebra operators that we learned last time. And just by way of refreshing your memories here, a select operates on a relation R and has a predicate that defines the conditions for the records that it wants to select from R. So that's the select. The project identifies which fields you want to return from the specific operation. And the other one that's important, most important, I should have put higher, is the join. The join joins two tables together, specifies the on which that join needs to take place. So this is kind of a cheat sheet for the relational operators. And, we've also got union, intersection, and difference that operates on two different sets. And we've got Cartesian product, which we never really use. And we've got assign and rename. So those are here. And we're going to do some exercises today. And we're going to do an exercise on this database. So let me bring up this slide here so that you can see this. Now, you guys have an assignment to beginning of next week to identify 3 tables for Netflix. And I got a question at the beginning of class. What form should those table, or what form should that assignment take when you hand it in? Well, you can provide me with a table that has a couple of sample items in it. That's one way you can provide. Or you can provide a table description using this kind of schema. Okay, so here I've described 4 different tables in a recipe database. The first table is called recipe, and it has a recipe ID, a recipe name, and the number of servings that recipe produces. Okay, so that's the first table in my database here. The second table in my database is a recipe item. And I need a recipe ID to say what recipe that's a part of. So that identifies the recipe. And then it says what the ingredient ID is. So that identifies the ingredient that's part of the recipe. And then the ounces say how much of that ingredient needs to be in the recipe. Are you guys okay with this so far? Do these 2 tables make sense so far? Anybody not, please speak up. The third table is called the ingredient table. And that uses an ingredient ID. It has an ingredient name, and it has a description of what the ingredient is. Okay, and the last table is the grocery inventory. It has the name of a store. It has the identifier for the ingredient that somebody might be shopping for. it has the section name of where that ingredient can be found, you know, produce, meat department, whatever. And it has the aisle number in that store. And it has the number of packages of that ingredient the store has, and how many ounces each of those packages have. Okay, so that's the definition of my recipe database. And I have a little model here, you know, we're still learning ER models, but I put together a little model to show how these different things relate to one another. You know, a recipe contains a recipe item. A recipe item specifies, so a recipe contains many recipe items. Recipe items specify an ingredient, and that ingredient could be used in many recipes. So, you know, that's that many symbol there. So the recipe item specifies one and only one ingredient. And that ingredient can be found at different grocery stores. So, you know, and that grocery store has, I should have said, several ingredients. So actually that should be, oh, I'm sorry, a grocery inventory only corresponds to one single ingredient. So there will be one of these records for an individual ingredient rather. All right, so that's my database. Does anybody have any questions on this database or anything? Yeah. You can specify what the table would look like with this notation. Okay. No, you don't have to put in all the entries in that table. You just have to specify what the table looks like. If you want to put in a few example entries in a table to show, you know, in a little spreadsheet to show what it might look like, that's fine as well, you know, if it's not clear. But this is a way that you can specify the tables in a database. Okay. So this is called the logical schema for this database. And it specifies each of the relations in the database. And it specifies each of the attributes of each of those relations in the database. Okay? And my little chart here helps to show, you know, how these things relate to one another. All right, so this is the database that we're going to be working with today. And I have a couple of questions I'm going to ask you right away about this database. What are the relations in this database? What is a good candidate key? That's a field or a set of fields that you would uniquely identify a record in each of the relations, or a tuple in each of the relations. What are the foreign keys in each relation, and what other relation do they reference? The last example is give an example of what a tuple would look like for each relation. So in your Word document, that hopefully, you know, you guys can start a new Word document. You know, try to answer these questions. I'll give you a couple of minutes to look at this database and try to answer those questions. It's going to be hard for me because I only have one screen here, so we might have to switch between them so that you remember the questions and the database. But, you know, question number one is, what are the relations in this database? So what are the relations in this database? On that. Okay, everybody good on that one? Anybody need more time on that one? All right, that one was hopefully a fairly easy one. Second question. What is a good candidate key for each of these relations? What field or fields, what attribute or attributes for relations would uniquely identify a tuple or record in this relation? That's question number two. So if you look at each of these relations, you should be able to identify which field or fields uniquely identify an item in, or a distinct tuple in this relation. Anybody need more time? Everybody good on that one? Okay. By the way, I'm not grading this or anything. This is just practice. This is so we get to know this stuff. This is a class exercise so that we get to know this stuff. All right. Next question. What are the foreign keys in each relation, and what table or what other relation do they reference? So foreign keys, essentially are the way of implementing lines, telling which records correspond to which record. So we need to identify what the foreign keys are that allow us to understand those relationships. We're good on that question? Anybody need more time? All right, if you don't speak up, I'll assume we're good. All right. Last question. Give an example of what a tuple would look like for each relation. So essentially, what would an example record look like for each of these relations? This one might take a little bit longer. That works today. Okay. So let's get started. Who wants to kick us off? What are the four relations in this database? Yes. Exactly right. The four relations are those right there. That is the correct answer to number one. All right. So let's start with recipe. What's a good candidate key for recipe? What field could be used to uniquely identify an entry in the recipe table? Yeah, that recipe ID would be a good candidate key. Okay, are there any others that might be a good candidate key in that table? Yeah. I'm sorry, which one? Which? Okay, not in recipe table. Yeah. Okay. All right, well, recipe name might be, it's not very reliable because you might have the same recipe that has, you might have two recipes that have the same name, but recipe name is another possible candidate. But, I think, I think recipe ID is probably preferable because you can ensure it unique. Yeah. Okay, what makes it a candidate key is that it would be uniquely assigned within that relation. But I'm going to get back to your question because your question is a good question. Let me, I promise I'll answer that question. Just give me a minute. Yeah, was there another question in the back? Oh. Okay, so what is the candidate key for recipe item? This one's a little harder. What field or fields would uniquely identify a recipe item? Yeah. Yeah, that's exactly right. That's exactly right. The candidate key for this table, in order to uniquely identify any record in this table, we need both of those things, right? So that would be our candidate key for that table. That was good because that was tricky. That's good answer. But we need both of those things to uniquely identify an entry in recipe item. All right, what's the candidate key? What are the candidate keys or candidate key and ingredient? Beautiful. Both of those could be candidate keys. Yes. We wouldn't need them both together, but we need one or the other, right? Yeah, good answer. So, once again, generally speaking, if you're picking a key for a table, you generally want to use a number because a number is easier. It's easier to keep unique and it's, at least from the database's point of view, it's a more unique identifier. But it's possible we could use an candidate key. But once again, we will identify the ID as being the unique. We'll use the ID as being the preferred key. All right, grocery inventory. This one is also difficult. What is the candidate key for grocery inventory? Yes. Does anybody think anything else? Anybody feel anything? Yeah. Section name, mile number. Any other thoughts there? Yeah. ID and quantity. One is hard. Yeah. Store name and section name. Okay. So the thing that would uniquely and this is the reason you guys are struggling with this a little bit is if we had some examples we could see, but generally, if I go to Stop and Shop and I'm looking for oregano, all I need to know is that I'm going to Stop and Shop, and then they can go and look up how much oregano they have, what aisle it's in, and all that good stuff, right? So if I go to Stop and Shop and say I'm looking for oregano, they can say, okay, well, we have oregano in our spices section. We have 10 packages on hand, 10 3-ounce packages on hand. Okay, now some of you can say, okay, well, what if they sell multiple size packages of oregano? Yeah, then we would need also, the ounces per package maybe, because we would need to specify what size oregano we need. Okay, so what the candidate key is here requires a little bit more understanding of what the structure of that table is. But the certainly need the store name and the ingredient item. And you'll need the ounces per package only if they carry, different size packages, right? Okay. The other one that we might have included here in this database, if we were expanding this database, likely the brand, then we would probably need to include that in our candidate key as well. So we would have a very complex candidate key for this. And, we look at that and we say, well, this gets a little too complex. Why don't I just give this an ID, grocery inventory ID. Then I can number these records sequentially. And I can uniquely identify them by a number. All right. So, sometimes the candidate key is going to be simple. Sometimes it's going to be compound, more than one field. And sometimes you're going to find it complex and you're going to have to find a way to simplify it in your database design. All right. All right, so now the question is, which one of these fields is a foreign key? So what a foreign key means, just to make sure we're clear on the definition here, is that if I have a key for a given table, if another table or relation refers to that table or refers to a record in that table, the reference that it uses will be the primary key of the reference table, but it will be a foreign key in that table. Does that make sense? Did I explain that right? So, for example, ingredient ID is the primary key for the ingredient relation. Okay. Where is ingredient ID a foreign key? It's a foreign key in grocery inventory. Yes, this ingredient ID refers to an ingredient in the ingredient table. So this ingredient ID is a foreign key in grocery inventory. I need a different color marker. This is the foreign key because it points to an ingredient in our ingredient table. Does that make sense to everybody? All right, what other foreign keys do we have? So here's one. Put a box around it. That's better. Boxes around foreign keys. There's one foreign key. Yeah. Description isn't a foreign key because it's not a primary key in any other relation. So it's not, it doesn't point to anything. Yeah, it has to be primary key in another relation. So if I have a recipe item, how do I know what recipe it belongs to? Yeah, recipe ID. This is another foreign key because this tells me what recipe I'm talking about, right? Yeah, so this ingredient ID is also a foreign key because it tells me what ingredient I'm talking about here. Did we miss any? Let's see. Got 1, 2, 3. Yeah. So you'll notice I've got 3 arrows here for my foreign keys. Let's label these arrows. All right. Call this one is contained by. We'll call this one is found at, and we'll call this one specifies. You see what I did there? All right. So, each one of these relationships that you have between these different things corresponds to a foreign key primary key pair that implements that relationship. Does that make sense to everybody? Everybody good with that so far? How am I doing? Am I doing all right? All right. So in order to implement these relationships between these tables, we need to identify a foreign key primary key pair to implement those relationships. And now, what have we built here? We've built a relational database schema. Okay. So, are you okay with this? Can I erase this down? I should have said, may I erase it? Because the issue of can I erase it is an issue of this whiteboard not letting go of this marker. That's problem the other day. And you know what? The good thing is, the only good thing about being in the middle of a pandemic is that we have wet wipes over there that I could use if I run into trouble. Erase all this with some elbow grease. My workout today. There we go. All right. So hopefully you guys are okay with this, and this helps with some of the definitions we've been using and helps you understand foreign keys and primary keys. The other thing I was hoping you guys would get out of this is you're starting to get a feel for the database design process. I have this diagram. This diagram tells me very nicely what the things are that I need if I'm specifying recipes and where to find them at the grocery store. You know, and I can talk to that diagram, I can explain that diagram to you. And you can say, well, you know, I got a question about this, or this doesn't make sense. You know, we can talk through that. But once we have agreement on this diagram, I then translate it into this. And that's the structure of my relational database. It includes the relations. You know, these would be your tables for Netflix, for example, if you were doing this for Netflix. I specify my relations. I specify what the attributes are that define them. I figure out what my primary keys are. And I figure out where I'm going to put my foreign keys to implement the relationships between these things. All right, so we're partway through the database design process. We've designed our first database. All right, or at least to the logical schema level. All right, who's ready for the next hard question? You guys ready to do some more work now? All right, let's do some work now. All right, so now I want to write something in my relational algebra. I'm going to query this database. I want to find the name of the store, the name of the ingredient, the quantity on hand, and the total number of ounces on hand for every ingredient, for each ingredient. So I want you guys to write me a relational algebra statement that answers this question for me, and I'll give you a few minutes. And I better refer back to the table so that you can see what you're writing it against. Go back and forth again. This is one case where I wish I had two projectors. Maybe I can solve that problem. Hang on, I'm going to solve that problem. Bear with me a second. I will get, you guys can keep working on that, and I will see if I can get you a side-by-side view of these things. Because after all, this operating system is called Windows, so I should be able to put these things in separate windows. So there's the database schema on the left. And you open a copy of the file. Oh, that one's already open. Okay, let me open the first copy of the file. There we go. And we can have the question on the right. If I do this right. It's question 2, question 1. There we go. much. There we go. How's that work? Does that work? Does that help? Better or worse? There we go. That's not bad. That's not bad. Okay. Anybody need more time? More time? Raise your hand. All right. More time? Give you another minute and then we'll go ahead. I mean, I want to get through a couple of these. All right. So before we get the answer, let's figure out the process. What's the first thing? When we were going through this last class, I gave you a way of doing these things. And the first thing I told you to do was identify which relations you need. Okay? So step one is to identify which relations you need to answer the question. Who can tell me what relations are needed to answer this question? Yeah. Exactly right. We need two tables or two relations to answer this question. We need ingredient and we need grocery items. And in my prescriptive description of how to do these things to you, I said, the first thing we need to do is we need to join those tables together. So we're going to do a join. And the symbol for join, if you'll remember, is this thing right here. So that's the first thing that we're going to do. And in this case, we're going to join ingredient. Ingredient and grocery item. Yeah, we only need these two relations, so this is good. This is a fairly simple one. So there we go. There's our join expression. But this join expression is not complete because we have to say on what condition we're going to join these, right? So when do we want to join records from these or tuples from these relations? What's the condition that goes? We want the ingredient IDs to match, right? We want to have the same ingredient ID in both tables. So we have to say ingredient ID equals grocery item. I'm going to abbreviate that GI if you guys don't mind. Equals grocery item dot ingredient ID. Okay, that's what we're joining on. So that was step one for this part. Everybody good with this so far? Okay. Now what do we need to do? We're saying that we're going to do this for each and every ingredient. So we don't need to restrict this joint in any way. You know, we're going to take everything that comes out of this joint. Now, if I said I only want it for certain ingredients, I might need to select out just those ingredients, right? But in this case, I don't need to select because I'm looking for it for every ingredient. Okay, but I do need something else. What else do I need? Yeah, a project, exactly right. So I need to put this in. Put this in a project. This whole thing needs to go in a project. And what that project is going to specify, I'll put my parenthesis a little further out to give myself some room. But what that project is going to specify is each of these fields that I want to find. Okay, so some of these are easy. You know, name of the store, who can tell me what the name of that attribute is? Yeah, which relation? Right. So I could say, since store name is unique, I don't have to say which relation. I can just say store name. But if there were multiple store names, I would have to say GI.store name, grocery item.store name. Yep. Yes, in fact, you have to. You have to. And we'll see this when we translate this into code. This is going to map into a SQL statement ultimately. You have to tell the SQL statement which fields you're talking about out of that. Okay, so store name is the first. All right, what's the next one? What's the name of the next attribute that we need? Yeah. Ingredient name. Yeah, what relation does that come from? Right. And once again, since it's the only field named ingredient name there, we don't provide the relation explicitly. But we'll put it in here. So store name, ingredient name. I'm running out of board space, but you guys get the idea. All right, now we need quantity on hand. Who can tell me the name of that attribute? Yeah, quantity. Yeah, once again, it's unique in this set of tables. It's only in grocery item. It's not an ingredient. So we can just say quantity. We don't have to say exactly which relation because it's implicit. All right, now comes the hard one. The hard one is total number of ounces on hand. Now, I don't see any attribute that says the total number of ounces on hand. I see ounces per package. And quantity tells me the number of packages. Okay. Exactly. So we can move this up, you guys, we have store name. This is a subscript, I'll make this thing bigger so it appears to be subscript here. There we go. That's better. Store name, ingredient name. Quantity. And in this case, our last field is a calculated field. It's quantity times ounces per package. And that's, make sure we close our parentheses, right? Because we're good programmers. And that's our relational algebra statement. Yeah, that's the word I'm looking for. How is everybody with this? Does this make sense? How are we doing? We good? Yeah. Does the order of the attributes matter? Did you say? Yeah, I see your question, yes. This is what's called transitive. We could have done this in either order. We could have joined, I'm glad you asked that. We could join ingredient with grocery item, or we could have joined grocery item with ingredient. It doesn't matter. What matters though is the order of the attributes and how we put them out. Great question. Okay, right. I forgot to answer your question before. I kind of answered it, but I didn't answer it explicitly. So I want to get back to your question also. You asked, is it a key if it's repeated in multiple tables? And that's how we got into the discussion of foreign key versus primary key. So I apologize for not getting back to you, but I just remembered. I'm like, I forgot to answer a question from earlier. There it is. All right. So you guys okay with this first one? You ready to do a second one? I got to keep an eye on time because I get into this stuff and then I lose track of time. So, all right, let's do a second one here. Where's my mouse? There it is. All right, question number 2. There we go. So we want to find the name of all recipes that use both tomatoes and onions as an ingredient. It's not too bad either. You guys are working on that. I'm going to erase this. You guys do your work. This one is a little bit more interesting. I forgot why I put this as question number 2, but I just remembered. Yeah. If you do a joint statement without a condition statement, you're essentially doing a Cartesian product. Okay. More time? More time? All right, let's do it step by step. So what relations do we need to answer this question? This one's a little harder than the last one. Yeah. Yeah, I said this was harder. How'd you do that so quickly? Very nice. You're proving me wrong. Very, very easy. Recipe. Made it look easy anyway. Recipe item. Ingredient. So much for this being hard, gosh. Nice job. All right, so the reason we need recipe items also, even though, the name of the recipe isn't in the recipe item and, the ingredient name isn't in the recipe item, is if we look at our diagram, for example, we see that there's no direct relationship between recipe and ingredient. The only relationship between recipe and ingredient is by way of recipe item. And that's why I use this example. I thought it was a good thing to show, and it we're supposed to stump you at least for a second or two. All right, so we need these three tables. So to pull together three tables, we have to do more than one join. We have to do two joins. So we need to join these tables together. And here, the order doesn't really matter. We keep them in any order as long as recipe item is in the middle, right? Recipe item has to be in the middle. So, we'll do it the way the diagram does it. Recipe, join, the item, join, ingredient. Doing our joints first. So our process says. And who can tell me what needs to be the predicate or the condition on that first join between recipe and recipe item? Yeah. Recipe dot recipe ID equals recipe item, which I will abbreviate RI in this case, because I'm running out of workspace, dot recipe ID. Okay, good. And who can tell me what the condition would be on the second join? Match up recipe item with ingredient. Yeah. Exactly. Recipe item dot ingredient ID equals ingredient dot ingredient ID. By the way, this is the second semester I'm teaching this class. I think I'm doing a much better job of this the first time than I did the first time I taught. It took me a couple of tries before I taught this well, but you guys are the beneficiaries of that because I think I'm teaching it better this time. So anyway, okay, so I'm using as evidence of that the fact that you guys are giving me all the right answers. All right, so that's our join. Now what do we do? Yeah, we need a select here. Wonderful artwork. All right. All right, and I'm gonna you're on fire, but I'm gonna put you on the bench for a minute. Does anybody want to tell me what the predicate is for these stuff here? You're also on fire. I'm also going to put you on the bench for a minute. Anybody else? Yeah, Zach. Ingredient name equals tomato. Yeah. Okay. Now, when we say, and then ingredient name equals onion, we need some kind of thing to tie those two things together. So, if we, yeah. I'm sorry. Maybe I'm calling you. Okay, I'm sorry.
Union?
Well, I'm gonna hold off on that. Actually, that is the right answer.
Oh, it is?
That is a right answer. So what we could do is we could use a union here. And what we would use a union of is we would repeat this exact statement again down here, except instead of the word tomato, we would have the word onion. Sorry, no, not union, intersection, sorry. Tomato or onion, we can use an intersection here. And instead of having, so that means it has tomato, remember when I said the intersection means the word and? So that's an intersection, and we could replace the word tomato with the word onion and write the same exact query down here. And that would be one way of writing this query. So, good thought. Intersection rather than union. And this would result in a fairly long statement because we have to repeat the same thing over again. But that is absolutely the correct answer. Is we could use set operations to take this set, intersected with the set that uses onions. So it uses tomato and onions both. The intersection of those sets. That would be one answer to this. There's another way to write this also, and we covered it a little while. We covered it a little bit quickly. Why you guys might not remember it. And I'll come back to the slide. But there's this symbol that means and. And we would say and ingredient name. Onion. Okay, and that would be a shorter way, but your way as well with the set operations. I'm sorry, your name is not Andrew then. What's your name? Mike, you should have corrected. I'm sorry, Mike. It's hard to tell people with math, but you would ask me a question that led me to believe that you were Andrew because Andrew asked me that same question in an email. So I'm sorry for confusing you guys, and I apologize for that. But I will get your name straight. All right, so this is another way of writing that. So there were two answers to this question, and we kind of got to both of them. So we're good on this one. Are we ready for a third one? These are progressing in difficulty. Oh yeah, the symbol. Let me show you that slide again, because I want to refresh that slide. Gotta find it. Oh, a little further back. Back to the select statement. There we go. All right, so here's the slide. We can combine several predicates into larger predicates by using the connectives and, or, and not. Okay, so put that in slideshow mode. And like I said, I covered that a little bit quickly, so you might not have fully appreciated that. But when we do a select operation, we can have a condition, and we can have more complex conditions by using those and, or, and not operators. Everybody good with that? This is a chapter in your book, and I forget offhand which chapter, but if you guys want to, if you guys are having some difficulty with this, you can read about this in the chapter in the book that corresponds to the relational algebra. But it is important to remember the and, or, not operations. The and the or are very similar in theory to the union and the intersection type of things, because the one that faces upward means or, and the one that faces downward means and. Okay? All right, so let's go on to question number 3. Let me go back to the schema here. Oh, I got right there. All right, question number 3. The names of all recipes that use ingredients that are sold in the produce section of ShopRite. So let's work on that a little bit. Let me hit a return here so that you can see the rest of that condition. There we go. That works nice. So that's the question we're trying to answer. So we can start the site again. Okay. What relations do we need for this one? That's absolutely right. We need all four relations in this one. We need recipe, item, ingredient, oh, feed, grocery, inventory. All right, what are we putting on this first joint here? What? Yes, that. All right, what are we putting on that second joint? Enter. A better way to think about this is what, uh, primary and foreign key relate recipe item and yeah, that's right. So it would be recipe item dot ingredient ID. Of ingredient dot ingredient ID. And lastly, how do we relate ingredient to grocery inventory? Primary and foreign key pair there that relate those two. Ingredient ID, right? Again, say ingredient dot ingredient ID. Both grocery item, not ingredient. Now, here's an interesting question. Could we have joined recipe item to grocery inventory first and then joined in ingredient? What do you think? That's honest. Well, truthfully, all we care about is that all these ingredient IDs match. So we can join them in any order we want. We can join them in any order we want. I prefer joining them this way because ingredients is kind of the common bond, but we could have joined them in any order we want. And if we wrote this as a programming expression, we could have written it either way. But in terms of organization, I think this is a better way to organize it. But as long as these conditions are met, we can join these in any order we want. In fact, well, we'll see that. All right, so that's the join statement. That's the inside of our expression. By the way, notice when I write these, I write them on subsequent lines for each subsequent thing. It makes it clear. So when you do your tests or your homework that involves this, you may want to think of, essentially putting each piece on a different line. All right, so now what do I need to do? What's my next step here? I'm going to put you on the bench again. That's a compliment. Yeah. That's good thing. We need to select some records here. And one of the conditions is that the store name equals ShopRite. Now we don't have to say grocery inventory dot store name because that's the only store name in here, so that's all right. Let's see if I can get somebody else. Somebody else want to tell me what else I need here? Yeah,
The section name,
yeah, produce.
section equals.
Yeah, so is that an and or an or? Yeah, it's an and, exactly. Name. Produce. Yeah. All right. Now we need one more thing. We need. Yep. Find it. And how do we find it? Yeah, we're looking for the recipe name. So what operation do we need for that? You're still on the bench, and that's a compliment. Yeah. For Jack, exactly right. And what are we going to as our parameter in this project? Recipe name, right? I put parentheses around my select, which has parentheses around my join. So I got two sets of. So I got my two sets of parentheses, and that's my statement, and my statement is complete. And we have solved, which is this question number 3. Okay, I am going to pause there. How are you guys feeling about this? Getting the hang of it? Is it making sense to you? All right, good. So this is exactly the process that we're going to go through when we get into the physical implementation stuff also. You know, we are going to be writing queries. We're going to use a slightly different language to express them. But you guys have started as a result of this class that we had today and the one that we had earlier in the week to think what I call relationally. Relationally. Yeah, so you guys are starting to understand the relational model, and that's great. So we're using a series of projects and joins and things like that. Now, one thing I did want to mention is that in one of our examples, we had a formula. One of our queries, and I'll just call it, you know, for now, I'll just call it query Q. Yeah, there we go. One of our queries had this calculation that said quantity times ounces per package. You guys remember that query? Okay. So we have this calculation in here, and that was one of the things that we projected at the end of that query to return the field. Now, you know, if we wanted to, you know, we may not want to use that whenever we want to reference that value. We may want to give that thing a name, right? And that's when we would use a rename. Okay, so we would do a rename of that. And we would call that total, what did we call it in the query? We called it total number of ounces on hand. Rename this total on to reflect that and give that a new name. And that's when we would use things like the rename. The other thing we could do is if we were going to take one of these queries and use it later on, we could do that whole assignment that says, you know, the letter Q is going to be that whole algebraic statement that we had later on. So that would be an assigned statement. So we didn't do those explicitly, but you know, those are how those would be used if we were going to use them in our relational algebra. So, you know, occasionally you might be asked to rename an attribute. If you need asked to rename an attribute, you would use the rename operation. And if you were asked to give a name to a query or a whole algebraic statement, let's say, or a section of an algebraic statement, you might use the assign statement. All right, that's where I want to end things. I think the one thing I will remind you of is that you have an assignment due, I think it's Tuesday. Correct me if I'm wrong. And the assignment Tuesday is to specify 3 tables in Netflix. And what your specification should look like, or can look like, is it can look like this logical schema here. But you're going to have 3 relations rather than 4. And please keep in mind, not requiring you to say what your primary keys are and what your foreign. You're going to have in mind that you need to relate your 3 tables via the foreign and primary keys. So keep that in mind when you do your tables. Make sure to include the foreign keys that are necessary to tie them together or the primary keys that are necessary to tie them together. Okay, anybody have any questions on that? Was this fun? Seriously, I'm serious. Or am I just such a big geek that I find this fun when nobody else does? That could be the answer. I mean, maybe that's a fair answer. All right. All right, we're done. Thank you.